Hello and welcome to GDG Cape Town's meetup, which we have titled A Deep Dive into Jetpack Compose. Hello and welcome to GDG Cape Town. Who are we and what are we about? Well, we are an official Google developer group. We are self-organized and independent, but supported by Google and our local sponsors. All speakers are organizers and volunteers. So you can also talk to us about future speakers or topics or sponsorships. So how can you touch with us? Just realized I was on mute. I'll start again, not to worry. Okay, so welcome everyone to our meetup, a deep dive into Jetpack Compose. You are watching GDG Cape Town, and to understand more about what we're about, we are an official Google Developer Group chapter. We are self-organized and independent, but supported by Google and our local sponsors. All speakers and organizers are volunteers. And you can talk to us about any future speakers or topics or sponsorships. So how can you actually get in touch with us? Well, you can join the chapter, which can be found on gdg.community.dev/gdg-cape-town. And then on Twitter, you can find us at GDG Cape Town. So GDG, capital C and capital T. And then you can also email us gdgcapetown@gmail.com, or you can find us on ZA Tech, which is a Slack or workspace, and look for the GDG-CPT channel, or you can ping one of the organizers. And who are these organizers, you ask? Well, there's Maya Grotepas, there's Sylvia Dickman, George Ngete, and then there's me, Ahmed Tikiwa. Also, please take a look at our code of conduct, which you can find at developers.google.com/community guidelines. So who are our sponsors? Our amazing sponsors are Peach Payments and Google, and we are very grateful to both of them and their sponsorships. And then on today's agenda, we've got Nick Roth, who will be talking to us about custom design systems in Compose. Then we've got Thomas Kuneth, who will be talking to us about Make Your Compose UI Foldable. And then we're going to have a panel discussion, if time allows, at the end. So in the chat, you can feel free to just post your questions there. Just post them, and then we will add them to the stream at the end of each talk, as well as during the panel discussion. So without any further ado, I'm going to bring up our first speaker, Nick. Hey, Nick.
Hey, everyone. Hey, Ahmed, how are you doing?
I'm good, man. How are you, man?
Very good, thank you. Let me share my screen.
Okay.
1 sec. Hoping everyone can see this. Yeah, so I guess assuming everyone can, I'll go right ahead. So hi, everyone. I'm Nick Roth. I'm an Android developer relations engineer at Google. And you can follow me on most places at Rick Naut. And today I'm going to be talking about custom design systems in Jetpack Compose. So for those of you who might have been doing Android development for a while and dealing with Google products as a whole, you'll know perhaps that material design is Google's recommended design system. But in the real world, what tends to happen is that folks tend to have either a sort of like a customized version of material design, like the design team will build on top of it, or you'll have a completely independent design system from material. And this is actually fine. You don't have to use material design, and also you don't have to use the library implementations that Google ships in both Android views and Jetpack Compose for these. You can go ahead and implement your own design system and use the lower level APIs to do this yourself. So that's actually what we're going to take a look at today and do a bit of a deep dive into how you can go about doing this and what, basically, first of all, like look at how material theming works in a very, very brief nutshell, and then more go into like the anatomy of how that works under the hood, because there's quite a lot of abstractions on top of that. And then go into 3 different approaches for how you can do custom design systems to varying degrees of complexity. So things like extending material theming, so using material theming but building on top of it, replacing material systems, so taking out one of the things like color theming in material design and replacing it with your own implementation, or implementing a fully custom design system where you don't use material design at all and instead build it from scratch yourself. We'll then also take a brief look at how you might use a custom design system but still end up using the material components, things like buttons, radio buttons, chips, etc., with a custom design system. So let's start off by looking at material theming. This is sort of the easier way, or the entry-level approach to theming with Jetpack Compose. So we'll start off by taking a look at 2 variations of material design. If you haven't heard, material design is now split into 2 versions because there was Material U introduced with Android 12. So we basically have Material Design 2 and Material Design 3, and they both come with their own Jetpack Compose library. Starting with Material Design 2, which is the more mature library right now, you can implement a material theme by using the material theme composable, pass it colors, typography, and shapes. These are the 3 systems of material theming, which the material components and other parts of your app will use in a theming way. With Material Design 3 / Material U, it's very similar. In fact, the composable name is exactly the same, except the parameters are slightly different. There isn't any shape theming at the moment, but you do pass through a color scheme and typography. If you want to learn more about material theming in Jetpack Compose, there is a link in the slides and there's documentation on developer.android.com. But that's not the topic of today's presentation, so I'm going to be very brief in this regard and then jump straight into, okay, cool. So this is a material theme, but how does it actually work under the hood? First, I also just want to point out that you can then access material theming values in your app if you set up either a Material Design 2 or Material Design 3 theme by using this dot notation, material theme.colorscheme.primary, for example, or material theme.typography.body small. That's how you like get the theming values once you've actually wrapped your app in a material theme. Then you can use it in something like a text composable and change its color and text style to be something like your primary color and the body small text style. Just a very brief, simple example. So now I want to take a look at how this actually works under the hood. We've seen the sort of high-level abstraction of how you wrap your app in a material theme and how you access those theming values if you want to use them in your app. But how does that all really work? So by inspecting the source code of material theme, we can see that this is just a composable function. It's no surprise that it accepts the parameters that we've seen before that we'll pass to it in our app, things like color scheme and typography. And then this third parameter, which is a content parameter. We'll take a look at each of these and just see what they are. Starting off with the color scheme and typography. What these are actually just classes, Kotlin classes that model a particular material system, a theming system, if you will, which is like effectively a way of grouping together values that are in a familiar family. So in this case, we've got a bunch of colors. You can see on the right illustration of what these colors sort of represent, but this class holds all of these values, things like your primary color, on primary color, primary container, etc. The same can be said for the for typography. It's just a class that that has a bunch of values and is strictly typed, so to speak, and accepts parameters like body small, body large, etc. to model again the material design typography system. The third parameter is this content parameter, which is actually allows you to nest have a trailing lambda to nest your app content. So all that really allows you to do is basically provide a material theme and then have a trailing lambda in which your app content goes, basically just other composables that become themed by this material theme. But the interesting stuff of how this all works actually happens inside this function. The parameters we've seen, we probably would have dealt with by using a material theme in our app, but what actually happens inside this function? And again, we have to look to the source code for this. And although this is a slightly simplified version, the main part of this is something that you see here, which is called a composition local provider. And then a bunch of the values passed in, which are a local color scheme, which provides color scheme, a local typography, which provides typography, and the content which we saw before, which we passed through to this composition local provider. So we're going to dig into a bit of that and see what all of this means. We're going to start off with the composition local provider. For that, we need to actually just talk a little bit about something called locally scoped data in Jetpack Compose. So a composition local is basically a tool for passing data down through a composition implicitly. Effectively, this like tree of composable functions that forms your UI. So usually in Compose, like data flows down through the UI tree as parameters to each composable function. So sometimes what you have to do is like pass through a value to multiple functions that are nested to each other. And this makes these dependencies explicit. However, this can sometimes be cumbersome for data that is very frequently and widely used, such as colors and type styles. You can imagine basically like if you didn't have a theming system in place, you might have to pass through a color all the way up from your like top level app composable down to the UI that then uses it. So there might be like multiple levels deep in a button, then finally has to use a color and a type style, which can really bloat your code quite a bit. So to support not needing to pass values as explicit parameters to most composables, this is where composition local comes in. It allows you to basically create tree-scoped named objects that can be used in an implicit way to have data flow through the UI tree. So it's effectively like an omnipresent parameter that you don't have to pass through to each function. Now that we've had a look at some of the theory, we can see here that what we have is this something called a composition local provider, which provides composition locals down the UI tree for Jetpack Compose. In our case, it's these two things here, local color scheme, which provides the color scheme, which is a parameter to material theme, and local typography, which provides typography. Let's take a look at those. So all these really are instances of composition locals. We create them with this static composition local of, which is a function that creates a composition local and pass it a default value. And this is all it really is. These are composition locals that model both the color scheme and typography classes and provide them implicitly down the UI tree. So when you actually want to access the value of a composition local, you'd normally do it like this. So you'd say local color scheme dot current dot primary or local typography dot current dot body small. This would happen inside your app within the theme. So then how does this work? Why does material theme have this special notation where you say something like material theme dot color scheme dot primary, and like how did material theme get this sort of special use case? Well, as it turns out, it's not that special. All it really is a nicer way and a more idiomatic way, perhaps, to access theming values. And if we have a look at the source code again, we can see that what the Compose material developers have done is that they've instead created an object which is named the same as our function material theme. So we have an object material theme. And within those, they create a value and then override the getter to be local color scheme.current. So that's this notation that you see here. Really, all it is just a wrapper over that normal way to access the current value of a composition local. And this allows us to do the sort of nice material theme.color scheme.primary, so you know what you're getting and which theming values you're trying to get. Same can be said for the typography object. It's just another, the typography value, which is just another value in this object, which allows us to get the composition local for typography. So in a nutshell, let's take a look at the anatomy of a theme in Compose using the example of a material theme as our case study. So here we've got 4 things. We've effectively got theme system classes. An example from Material 3's theme is a color scheme. But then we have other things like typography, other things like shapes. These are just classes that model a system of a design system, basically, a subsystem of a design system. We've then got composition locals that are used to provide these systems to all parts of your composed work. So in our case, an example would be local color scheme. We then have a theme function, which wraps all of this together. So the theme function then uses composition local provider to provide something like the color scheme. Lastly, we have this convenience accessor, an object which is named the same as our theme, which just allows us to do something like theme.colors.primary. So these 4 things are sort of the pillars of what a theme is in Jetpack Compose. And knowing that, we can actually use that knowledge, which is all freely available and visible and open source, by the way, to extend material theming and basically create custom design systems for ourselves. So let's start by looking at a simple use case or simpler use case of extending material theming. So Compose material closely models material theming. It's a design specification that lives on material.io, and it's effectively like a Kotlin implementation of that, and it makes it simple and type safe to follow material guidelines. But it is possible to extend the color, typography, and shape sets with additional values, and this tends to be a fairly common use case in my experience in companies that use material design. The first and most simplest way that we could potentially do this is actually to use Kotlin extension properties. We don't even have to go into the whole composition locals and the approach that material theme takes. We can do this for something like, we can basically take that colors class, which is that system class, or the typography class, and create extension properties on top of those, which then allow us to access those in the same way that we would do our normal material theming values. So something like a snack bar action color or a text field input color. A word of caution here, though, that this approach is only really recommended for simple theming value additions or for values that are the same in different themes. If you happen to have 2 implementations of a material theme in your app, perhaps like for a subsection of your UI or for a different screen, by creating an extension property, it's going to be the same regardless of the theme. So you need to keep that in mind. Then if you have multiple themes, it's actually better to define a new class with new properties instead, which is what we're going to dive into next. So let's create an extended theme rather. Let's go slightly deeper, dive a bit deeper, and actually bolt on more theming values onto the material theme in the same way that it implements its theme under the hood in Compose. And our use case here, or our example here, is to add 2 additional colors to the material theme color palette, tertiary and untertiary, which don't exist in the baseline values. But we still want to keep the existing material colors and all the other material things that that come with the baseline implementation. So first, we need to start by creating a new class. Here, I've used a data class called extended colors, and I've added 2 colors to it, just tertiary and untertiary. You'll see that they use the color class, which is part of Compose's foundation. And you'll notice there's an annotation there called immutable, which is effectively a signal to the Compose compiler of how to retain or not retain its class. There's a bit more detail around that in the documentation, and I won't go into it too much right now, but there is links to that in the docs on developer.android.com, again linked in the slide. So we've made a simple data class with 2 values, tertiary and untertiary. We then need to create a composition local of that. So we're again using static composition local of, passing it an extended colors instance, which is just going to be our default values. And then here we're just using color.unspecified as our defaults because we don't want to assume any particular defaults for extended colors implementation. We then create our theme function, which I've named extended theme. And the initial parameters for this are going to be all the things that you would expect to pass to a material theme, because remember that we want to keep all the material theming values. Our additional extended colors parameter, which is going to model our extended colors, and then our content parameter. We then use, in the same way that material theme does, composition local provider, and then we use that composition local extended colors to provide our extended colors, which is passed through as parameter to our function. And within that, we still need to call material theme because we do want to actually provide all the other material values like colors, typography, and shapes, and pass those values through to it, as well as our contents parameter. Lastly, we need to create that object, which allows us to grab the extended colors in a more convenient way. So here I've created an object, it's the same name as my theme, provided a colors value, and then just use the getter to have local extended colors.current. And then what you end up with is something like this. So when we actually want to use this extended theme, we will create an extended colors instance, and we pass through some colors that you can see on the right, which the designer has provided. We then actually call the extended theme function and pass through the extended colors value that we've created. And then we can start using it in our app in any normal, and in the same way that we would do material theme dot colors, we can now do extended theme dot extended colors. So that was a look at extending material theming with additional values. What happens if you want to actually replace one of the material systems? It's like colors, typography, or shapes, and like remove one of them or put a different one in, and basically like rejig some of the actual core systems of material design, but keep some of them in place. So instead of extending material theming, you may wish to replace like one or more of these systems with a custom implementation, but you may want to maintain the others. So the example we've got here is that we want to keep the color system, so all the material colors, but we actually don't want to use the material typography system or shape system. We want to get rid of those and instead provide our own implementations of typography and shapes. How do we do that? So firstly, we're going to actually follow a very similar approach to what we did for extending the theme. In fact, you'll see this throughout, that there's a very standard approach to doing this. So I've again made a data class for replacement typography using that diagram on the right that I got from the designer to model this class. And the same can be said for replacement shapes. We create two composition locals of these, again passing in some defaults. So in our case, it's going to be replacement shapes and replacement typography. We create this replacement theme function again, and you'll notice here that the parameters only accept the material colors parameter. There's no material typography or material shapes. Instead, we pass through our own implementations of these, as well as the content parameter. We then use composition local provider again to provide our local replacement typography and replacement shapes. And then we still need to, again, use material theme because we want to maintain the material colors and pass through that colors object to this material theme, as well as our contents. Lastly, we create this object again to help us with like this convenience access object for our replacement typography and shapes. And then how does this look in practice? So say we want to actually do the implementation on the right with our certain title style and body style and component and surface shapes. I've made two example implementations here where I've instantiated a replacement typography and replacement shapes. I've passed this through to a replacement theme. I'm calling that function, as well as the colors that I would have gotten from somewhere else and instantiated for the material theme. Then our app content can begin using these theming values with replacement theme, replacement typography, or replacement shapes. Lastly, I want to take a look at implementing a fully custom design system. So that's going to be effectively replace material theming altogether with your own fully custom design system. So a design system in theory is not limited to the concepts material relies on. It's really just a way of grouping together these systems that model a particular reusable thing that the components of your app will use. So you can actually modify existing systems or take inspiration from the material ones or introduce entirely new ones that aren't in material, that aren't typically themable, with new classes and types to basically make themes compatible with another system that you or your team or your design team can envision. So here we've got a custom theme, which doesn't use any material values at all. it's got a colors system, and it's got a typography system, and it's got an elevation system. So our colors look quite similar to the material ones, but instead we've actually got a gradient, which is modeled by a list of colors. Our typography is quite similar to material, but it's only got 2 values, and elevation, which is actually not part of the normal material theme, is something that we're modeling for a default state and a press state, which we could then provide to components to say, yeah, this is your elevation when in normal state, and this is your elevation in press state. So we're going to actually follow, again, really similar to what we've seen before, creating data classes of our custom colors using the relevant types, our custom typography, and our custom elevation. These are all types that are provided by Composer Foundation, by the way, things like color or list of colors or textile or DP, which models like elevation. We then need to create our composition locals once again. So here's one for our custom colors and using relevant default values. Here's our custom typography. And lastly, here's our custom elevation. You'll notice that Composer has all of these like basically unspecified or default or empty values, which I would recommend using in these instances, because a default value of a composition local should not really assume or be opinionated about what the value of like a color is or a gradient or a textile. We then create our custom theme function. So in this case, we're not accepting any parameters that come from material. We've just got our custom colors, custom typography, and custom elevation, and our content. We again use composition local provider, providing our custom colors, custom typography, and custom elevation. And actually here, this is where it stops. At this stage, we don't have to call material theme because we aren't using any of the values from it, and we wanted to create our own entirely custom design system. We then just pass through the content rather to the composition local provider directly. To make accessing these values simpler, again, we use an object called custom theme and have values like colors, typography, and elevation, which have the types of all of our custom classes that we've created. Using it is, again, very simple and very similar to what we've seen before. We create instances of custom colors, custom typography, and custom elevation, which you can see on the diagram on the right. We then pass that through to the custom theme, calling this function, and then our app can start using our custom theme values by things like custom theme.custom colors, custom typography, and custom elevation. The last topic I want to touch on is using material components in a world where you've implemented a custom design system in this way. While you may want to tweak your theme and maybe even entirely replace material theme to provide different themable values or extend on top of material, you may still wish to actually use the pre-built material components, things like buttons, things like chips, cards, etc. These components are actually built to have their default values come from material theme. So if you were to use them in a case where, let's say, use a fully custom design system, their defaults are going to be kind of strange. They're not going to be able to find the theming values, and they may not work as you expect out of the box. So you need to do a bit of workarounds here, depending on the extent of your custom design system. So firstly, if you're using an extended theme, you're going to want to have this approach, which I'm going to call wrapping a material component. What this is doing is like having a function which is wrapping the existing material composable function that provides it with the values from your custom theme. So here, in this case, we set it up by effectively just creating a composable function called extended button and passing through all the sort of like standard parameters, an on-click listener, a modifier, and content. We can then introduce like additional values here. So over and above these standard parameters that allow us to theme our button with values from our custom extended theme. So in this case, with the button, we override its default to rather use colors from our extended theme as opposed to colors from material theme. And what this is going to do is that mean that we can have a button that uses that tertiary or on-tertiary color for the button and its label or icon in a way that wasn't possible before. If you're replacing a material system, you need to take a slightly different approach. So you need to make sure that, because now that you've removed one of the material systems, and most material components will use aspects of colors, typography, or shape, you need to make sure that there's at least a reasonable default in there, or that it's coming from your replacement theme, so that the components behave as you would expect. Again, we do this basic setup of having these sort of like standard parameters, and then passing those through to the button. You'll notice here that we don't pass through the content, and that's for a good reason. The reason for that is that because our content is where text styles tend to be used, we need to wrap our content in another function that provides our replacement themes typography to any label, which would be in the form of a text composable within it. We also then override the shape parameter to come from our replacement theme. And what this is going to do is just mean that our shape theming values and our typography theming values are going to be used in this button over and above the material theme ones. But importantly, because we've maintained the material theming color system, those colors will still be in place. Lastly, if you're using a fully custom theme, i.e. there's no material theme present, using material components as is will basically result in unwanted colors, types, and shape values all over the place, because they're just going to be having sort of like unspecified values in place, which Compose tends to interpret as something like just black or white or whatever makes reasonable sense. So if you want to wrap a button for a fully custom theme, again, setup is providing standard parameters and passing those through to the button. But you then need to actually override quite a few values here. So in this case, our button relies on the material theming system, so you need to provide colors to it. Usually you have to override most of the colors in this button colors object, so things like our background color and content color, but also things like our disabled background color and disabled content color, because sometimes we'd leave those to come from the material theme, but in this case, there's no material theme whatsoever. We need to do the same for shape. And in this case, because our design system, our custom design system, actually has no concept of a shape system, which you'll see in the diagram on the right, we will have to either hard code those in place using the foundation functions like rounded corner shape or cut corner shape, or potentially just abstract that to a value somewhere that can be used. And we can then also override its elevation, which is something that the button composable does accept, with values from our new custom theme, which actually wasn't possible with material theme before, which is pretty cool. And that is about it. That's all I have for you today. I see there's a bunch of comments in the chat, and I really appreciate that. So I'm going to maybe take a look and see if anyone has any questions. But for now, that's all I have to show you.
Oh, very nice, man. Very nice, very nice. I'm actually very excited to implement everything that you actually discussed today. I'm just excited. You know, Compose just gets me really really excited. Yeah, so we actually have a question. So if we're creating a Compose theme in an existing view-based app by using MDC theme, how can we still have custom colors in the XML theme and make them available in the MDC theme?
It's a very good question. For those of you who don't know, there's a separate small library that I actually maintain called MDC Android Compose Theme Adapter. What that does is it's a composable that extracts theming values from a context in a view-based app and makes them available in Compose. And yeah, I can drop a link, or actually I can find a link to that and drop it in the chat if you're not familiar with it. But at this point in time, it's actually not set up to handle custom theming values that come from your XML theme to make them available in Compose. With that being said, it is something that I'm aware of. It is a feature request that I'm strongly considering, and I would say watch the space. But right now, when you use that, you're kind of stuck with the main material theming, or the vanilla material theme composable. However, with that being said, now that I'm thinking about it, Oh wait, no, that wouldn't work. But you could do something like extend that, like with the first approach that I showed in these slides, but it would end up lead to some recreation of like what you did in XML. So it's kind of besides the point. But good question, good feature request. It's on the to-do list.
Awesome. Thanks, Nick, for that answer.
Cool.
Yes, I hope that answers the question. Whoever asked that question, I'm assuming it's Maya. Yeah, those are the only questions that we have. So I'll bring you up again for the discussion at the end. Yeah, thank you so much, Nick. See you soon.
Yeah, thanks so much, everyone.
Cool. Okay, so next we are going to bring Thomas onto the stage. Hey, Thomas.
Hi, Ahmed. Hi, everyone. Ahmed, how are you doing?
I am good, man. I'm good. It is almost Friday, so as you can see, my smile is bigger.
Actually, I'm also looking forward to the weekend.
Oh yes. Yeah. Let me just bring your slides up, and yeah, I will leave you to it, man.
All right. Once again, hello, everyone. In the next 20 minutes or so, I'd like to introduce you to foldable devices. But first of all, thanks very much for having me back at GDG Cape Town. Last September, I had a talk about Jetpack Compose implementing a retro style game, and it's good to be back. So, like I said, thanks for having me. I'm happy to be a Google Developer Expert for Android since last year, but actually I've been doing Android programming since 2009, and along the way I wrote a couple of books. Most of them are written in German, but the last one, Android UI Development with Jetpack Compose, fortunately is in English. So if you're interested in learning a little bit more about Jetpack Compose, maybe you want to give it a try. So, like I said, we are going to talk about foldable devices. Actually, this is a pretty new device category. When the first devices appeared a few years ago, they quickly made headlines because they were not that durable, at least not as durable as the price tag made us hope for. Like in all first generation devices, these things happen. So the device manufacturers sort of fix these things, and I think the latest devices are durable enough, at least most of the time. If we look at the devices that are available at the moment, we can see sort of three archetypes of devices, and now let's briefly look at them. The first one is very compact. Usually it must be open for full usage, and the screen actually is smartphone sized. Now, the second archetype feels like a smartphone when it's closed, but when it's opened, it essentially becomes a tablet. And the third device category provides some sort of book-like experience. Typically, we see a hinge, which allows us to fold the device in a 360 degrees angle. And you can use the device in various postures. Like I said, you can use it like you would be holding a book, or you can use it like a tent, which makes an really awesome alarm clock, or you can put it half open on your desk and watch videos. Well, on the next two slides, I will be showing you how using a foldable device looks like from an app perspective. The first slide shows the Android emulator when run in foldable mode. It basically shows how an app responds to the device being folded or unfolded. So let's take a look at it. As you see right now, the device is folded, so it looks like an ordinary smartphone. Now I start opening it, and then you see that the app makes use of the extra screen real estate while when I fold the half of the screen back, it then again becomes an ordinary smartphone. Now the thing repeats. So let's go to the next slide. The next slide shows an emulator that simulates the Surface Duo by Microsoft, which is a dual screen device. Here the experience is like this. When you launch an app, it usually is open on the first screen, and by some drag and drop gesture, you can have the app expand to both screens. And as you can see, you can move the app around the screens and make it small, make it big again. And here I tried to dismiss it. It didn't work in the first place, but well, it's a small lag in the emulator. Now, this is how the experience is. What can we say about foldables? They may have 1, 2, or possibly even more physical screens. And these physical screens may relate to 1, 2, or possibly more display areas. Now, what's important, the biggest area may be provided by either one physical screen. In this case, this physical screen has some sort of fold. The latest Samsung foldables work like this. Or the biggest area can be provided by 2 physical screens, which are connected with a hinge. And this is like the Surface Duo devices from Microsoft work. Now, the thing about the hinges, it may block or obstruct parts of the display. Please note that having a hinge does not necessarily mean that parts of the display is blocked. Like I said, if the foldable device is made from one foldable screen, then there may be a fold, but that usually will not be noticeable, or at least it doesn't separate the 2 halves of the screen. But if we have a hinge and if it does block or obstruct parts of the display, it may look like this. On the left-hand side, you can see the book-like experience. Actually, I enjoy using my foldable device as a reading device very much, because it very nicely resembles the way you would be holding a book. And this experience is really great. If you look at the screenshot in the middle of the slide, here I'm playing a video. In a way, the hinge does make the UX a little less pleasing, but you can work around this by, like I said, turning the device and folding it halfway up. So the video is displayed on one half of the screen, and the other one can be used for any other parts the app may be providing. On the right-hand side, we see the phone app as it is currently on my Surface Duo. And as you can see here, clearly the UI needs some tweaking. First, we have the hinge obstructing parts of the content of the app, and additionally, the hinge also obstructs part of the, let's say, top level UI. Here we have bottom navigation, and the navigation item in the middle is barely visible, and this surely is something we need to fix. Fortunately, it can be fixed pretty easily, and that's what the remaining part of this talk is all about. Conceptually, we can divide the screen of a foldable device into 3 areas. I labeled them A, B, C. Obviously, A and C represent parts that can actually contain the UI element of the app, whereas B is the hinge that may block or obstruct the content. So what we need to do in our app is find out where these 3 areas are and how big they are. And once we have obtained that knowledge, we need to define our UI in a way that the hinge, that is area B, does not interfere with the user interface. So how do we do that? How do we do that? The user interface certainly must be laid out accordingly. And now the important thing is for tablets, using a 2-column mode worked pretty well. And as foldables are like tablets with a hinge or a fold between the two halves, using a 2-column mode should work equally well. Before I turn to the next slide, allow me to remind you that having 2 columns does not necessarily mean that the 2 halves are of equal size. If we look at typical tablet apps, we usually have a distribution of 33 to 66%, meaning that the left-hand side usually takes 1/3 of the space that is available horizontally, and the right-hand side is 2/3. But this would not work too well for foldable devices, especially if the foldable device has 2 similarly sized screens. So having 2 columns that have a 50% to a 50% ratio will give us a very smooth experience. And now let's see how this works. So let's see how these 2 columns will help us make nice, good-looking user interfaces. Before we do that, creating 2-column layouts has always been easy using classic views, and it certainly is equally easy using Jetpack Compose. But the interesting question is, what about the hinge? How do we deal with it? How do we get its features? And what do we need to do to work around it? Fortunately, there's a library for that. It's called Jetpack Window Manager. It's part of the Jetpack library of components. And, well, let's see how it works. The main idea of Jetpack Window Manager is to support new device form factors, and as we need on the Surface Duo, also support multi-window environments. It does so by providing a common API service for all platform versions, starting with API level 14. The initial release targets foldable devices, but Google told us that future versions may embrace additional devices and additional features. So what does it do? Basically, there are 2 main areas where we get help. It helps us computing window metrics. You'll see soon for why we need that. And the second thing is it helps us getting window layout information. It has a nice flow-centered API, but if we want to use Jetpack Window Manager with our legacy Java apps, we can do so too. It also supports other asynchronous APIs. Here's how to use it. The first line is mandatory, and the other ones are needed if you need Java-friendly API or if we want RX Java 2 or 3 integration. Here's how it is typically used. The first code snippet shows you how to get window matrix. We need to get an instance of a thing that's called a window matrix calculator. And on that object, we invoke compute current window matrix. Here we pass a context. And the second thing we can obtain is the window layout info. Here we see 2 possible approaches. The one in the middle is typically used for non-compose apps. Here I'm iterating over something that's called display features. You will see shortly what these display features are and what we can do with them. The last one is very compose friendly. We can get the window layout info as a state. This is what I am doing in my sample app. So let's see how this works. But before we do, let's take a closer look at what window layout actually is. What you see on the slide right now is a sample app of mine. It's called Window Manager Demo. It's no composer, but uses Android views and view binding. It basically prints out the current window metrics, and it basically prints out the window layout information. Here you can see that there are a couple of bits of information we can get about the hinge. For example, we can get its location and its size. And we can also find out if the hinge has a horizontal or vertical orientation. What's interesting is the so-called occlusion type. If, like here, it is set to full, this basically means that the hinge is obstructing parts of the user interface. So however we lay out our app, we need to make sure that no information lies beyond the hinge, because it won't be visible to the user. Is separating is a hint that the two parts of the screen are somewhat independent, meaning we probably should not have a video screen or text layout or something like this that stretches over the screen completely horizontally or vertically, because then again, parts may be obstructed by the hinge. Typical Samsung-like devices which do not have two physical screens, they might show occlusion type none. In this case, the information that there is a hinge is, or a fold in this case, is some sort of informational purposes, but we can continue to lay out our composables like we would on a tablet, because there is a hinge or fold, but it doesn't block or obstruct parts of the user interface. Here's how my sample app looks like on the Android emulator configured as a foldable device. Here we also have a hinge, but this hinge is only 1 pixel wide. So basically it doesn't do anything that makes the UX less pleasant. So if you are writing an app that should work great on foldable devices, I encourage you to use not only the Android emulator, but also get the emulator from Microsoft for the Surface Duo, because you probably should be testing your apps on devices with 2 physical screens as well, to really make sure that the experience is the way you want it to. Now let's take a look at some code. The sample app I will be discussing right now actually has 3 scenarios. The first scenario is if it runs on an ordinary smartphone, meaning no hinge or fold at all, or a hinge that does not block or obstruct any part of the user interface. If the app detects a device like this, it just shows one yellow box with a thin white border on all 4 sides. If, on the other hand, the app detects it runs on a tablet, that means larger screen with no hinge or fold, it shows 3 boxes, a red one, a green one, and a blue one. And the third use case is the one that's actually the most interesting for us. It's if we are on a foldable device and that device has a hinge, we are showing 2 rectangles, a red one and a green one. Now let's see what my code does to achieve this. First of all, here's the onCreate method, which basically sets up a compose app. As you can see, we have the set content. The set content gets a scaffold. The scaffold has a top app bar, and the actual, user interface comes from a composable function I call content. And what's interesting about content, it receives two parameters. The first one, matrix, is basically the window matrix that we got from the window matrix calculator, compute current window matrix. And the second parameter is the window layout info, and I get it by invoking collect state. As I'm using by, I do not pass the state to the composable function, but the actual value, which is the window layout information. So now let's see what we do with this. Basically, the content consists of a surface, which may be used in various Compose apps to provide some sort of background. We can use this to set colors and things like that, or set some things like elevation. That's not too important here. What is important, that the next thing I do is I compute the width of the screen by using local density dot current and passing the width of the window matrix. And once I have converted this to density independent pixels, I check if the screen width is less than 600 dps. If this is the case, then I assume I'm on a smartphone, and then I draw only the yellow box. Now, what's interesting here, I said that I check if I'm on a smartphone that has no hinge. That's not entirely true. I mean, even if there were a fold, I would not further work with it, because I think if the screen is less than 600 density independent pixels, it probably makes sense to treat the screen as it were an ordinary smartphone display. So, but what happens if the screen is at least 600 dp or wider? Here's where the interesting part regarding Jetpack Window Manager happens. Essentially, I'm computing 4 values. The first one, has gap, determines if there is a hinge, and we do this by getting a list of so-called display features from the window layout info. Display features basically describe some sort of anomalies that may happen to the screen. So far, only one display feature is handled by Jetpack Window Manager. It's called the folding feature. And this folding feature provides us the values you saw on the previous slide, where we get information about the hinge. And what I'm doing here is computing these 4 values based on the information I get from the window layout info. For example, I assume that the device has a gap if the occlusion type is set to full, and if the orientation of the hinge is vertical. Now, this means that if the device has a hinge that blocks or obstructs part of the screen, but the device is rotated so the hinge runs along the horizontal axis. Currently, my app does not react to this to make the code easier to read and to understand. In your app, you may want to target this situation as well. Now, you may be wondering what size left and size right represent. Actually, here I'm computing the width of the area to the left and to the right of the hinge. You will see shortly what we need this for. Actually, it happens on the next slides. So here is where we decide if we are going to show 2 colored boxes or 3 colored boxes. Please recall that if I determine that there is no gap, meaning there is either no hinge, or if the device is rotated so the hinge runs along the horizontal axis, then I assume tablet mode, meaning that I'm showing 3 colored boxes. That's in the else branch. And the interesting thing happens in the if branch, meaning if we determine that there is a gap. And here I'm using the sizes of the left and the right area to obtain a weight. Weight is something you may be familiar with from the classic linear layout. Basically, we could size parts or children of the linear layout by specifying weights, and fortunately Jetpack Compose has something similar, and I'm using the width of the 2 areas in combination with the width of the screen minus the width of the hinge to compute the weight. And actually this weight is just passed to another composable function. It's a small composable I implemented. It's called colored box with weight, where the weight is just passed. Now, what have we seen so far? We now know how we compute the 3 areas A, B, and C, which means that we can set up our user interface in a way that we have 2 columns, and we can populate the 2 columns, which are represented by A and C, in a way that we get a nice looking user interface. And we also have determined the features of the hinge, which was represented by the B area. What we haven't discussed so far is what will we do if the hinge obstructs part of some top-level UI elements. Here in this example, we have 2 top-level UI elements which are affected by the hinge. The first one is the app bar at the top of the screen, and the second one is the bottom navigation. So what do we do with this? So how can we make these parts, these user interface elements, hinge aware? Now you are seeing a clip which shows the app I called Navigation Rail Demo. This is because Jetpack Compose 1.1 received several new composables. One is called the Navigation Rail. Navigation Rail is the implementation of user interaction pattern provided by Material Design, which essentially is used to provide navigation where the navigation items are arranged vertically, and the spec says we should use the navigation rail on large screen devices like foldables or tablets. And my sample app showcases the navigation rail in a way that it is used when the device is rotated to landscape mode. And if it is not in landscape mode, but in portrait mode, I use the traditional bottom navigation. At the end of the slides, there is a resources section where I will provide you with links to my samples. But as I said, here's how the navigation rail works. And now let's briefly look at it in some more detail. The navigation rail is used to move between primary app destinations, like the bottom navigation is also used. It can display 3 to 7 destinations. It can have an optional floating action button, and it can have a logo inside the header. It is populated by so-called navigation rail items, which represent these primary destinations. Here's how this looks in code. We have the navigation rail, which receives the navigation rail items, which in turn receives an on-clicked lambda. It receives information whether it is selected or not. And we can set up an icon and a label. That's basically all about it. Time for some brief wrap-up. You've seen that the 2 columns work great for tablets and foldables, and with Jetpack Window Manager, we can determine both size and location of the hinge and the areas to the left-hand side and to the right-hand side of the hinge. Sometimes the hinge obstructs top-level elements. As you've seen, material design interaction patterns help us minimizing the impact. In some cases, there may be some more work to do. A few months ago, I did a short article on a dev tool called Hacking the Hinge. This is where I am looking into how to sort of hack away these issues. And like I said, here's the links to my sample apps. And that's about it. Thanks very much for listening. And I really hope you enjoyed listening to my talk. Thanks very much.
Very nice, Thomas. Very, very nice. There aren't any questions in the chat, but I'm just curious. So why the interest in foldables? Do you have a device, a foldable, and then you're like, no, I need to try and figure out how to decompose on this?
I have to confess, I'm what you probably would call a gadget junkie, meaning if there is any new device, I need to buy myself one. And I mean, Microsoft introduced the Surface Duo quite some time ago, but it took almost a year until we could buy one in Germany. And once I could, I needed to buy one. So yes, I do have a foldable device. It's the Surface Duo, and I needed to acquaint myself with it. But besides that, I think it's, from a developer's perspective, it's very important to know how to deal with these devices. But I think they will be gaining steam in the near future. I mean, for now, these things are awfully expensive, but I'd hope that in the months and years to come, the price tag will significantly drop, meaning that even more people can afford to buy them. And once there is a solid user base, we need to make sure that our apps work flawlessly on these devices. So that's why I'm sort of advocating foldable devices, because as you've seen, there is some work to be done to make our apps really shine on these devices. And that's, in a way, I consider this my mission to advocate these new devices. And one last thing, there might be a foldable device from Google sometime, and I surely need to buy this as well. So I need to justify buying new devices in a way.
No, I love it, man. I love it. I actually learned so much about foldables. Yeah, no, it does a really great talk. Thank you so much. We actually have a question from Catalin Gita. So he says, actually, I have one, which is a question, non-technical really. Do you think foldables are some products that will become popular? If so, we might need to invest time in learning how to deal with these devices?
Yeah, absolutely. It may take some time. I mean, if you look at the price tag, this is, speaking in euros, this is way beyond 1,000 euros, which is an awful lot of money. But like I said, I think the prices will drop sooner or later, and then these devices will become more popular, because the nice thing about them is, as you've seen, they can be really compact, meaning they can really nicely fit into the pocket. But once you open them, you get a really large screen real estate, which is a pleasure to use. So yes, I think they will gain popularity sooner or later. So we should acquaint ourselves with them.
Nice. Thank you. All right. So looking at the time, we do have time for a panel discussion. So I'm going to bring Nick and Maya onto the stage.
Hey, everyone.
Hey.
Hello.
Hi, Maya. Hi, Nick.
Hey.
Hey. Hey, everyone. Yeah, so I guess I'll kickstart. I actually do have a question. So Thomas, you've written a book tell us how that's going. What was the process like? How long did it take you to write? How is the feedback?
I started writing the book in July last year. It took me roughly 7 months, I think. No, 5 months. It was very exciting because it was my first book written in English, which is not my native tongue. So doing more than 200 pages in a foreign language was a little frightening at first, but I got some help from the publisher. And I mean, fortunately, I had been doing articles in the past, so it wasn't too new experience. But like I said, writing longer text in a foreign language can be sort of challenging, but I got along nicely. What probably is the most important thing when writing a book is making yourself some schedule, some time frame, and stick to this. I mean, imagine when you do the book not as your main job, but you do it in your spare time or after you did your regular job. You probably will be exhausted from your daily work, and forcing you to write an hour or 90 minutes each day to get the book done is something that may work most of the time, but it truly won't work each day. So you need to take into account that there are some days you just can't write anything because you're too exhausted. And it took some time in the past to learn how many pages I can write in a day. Fortunately, I got that from my German book, so I could set myself somewhat reliable time frame. But for new aspiring authors, this would probably be the most tricky part. Thinking, I surely can do 5 or 6 pages each day. Sorry, you probably won't be able to do that much. And learning how much you can do is really the interesting part.
Well, very nice, man. Yeah, so we actually have a question from Sylvia. So she says, Thomas, is your book topic related to your day job, or do you do all your research after hours?
In a way, it is related to my day job. I lead a small mobile team. So we do have clients that ask us to do mobile apps, but unfortunately, they tend to use other technologies. So partly I can use my Jetpack Compose knowledge, but not to the full potential. So basically, most of my Android stuff happened in my spare time. The company I've been waiting for comes from the Java enterprise ecosystem. Basically, that's why I came to Android in 2009, because I knew how to write Java apps. But yes, to some extent, it is part of my daily job, but not that much that I would wish for.
Nice. Maya, how are you doing?
I'm great, and I have questions.
Sure, fire away.
So it's probably for Nick, but I think because Ahmed has just recently done a talk on adding Compose to an existing app, and maybe Thomas because of the book. So we get some really nice guidelines from Google in the documents on like what possible migration strategies you can follow. You can either make a button and then slowly put the components of Compose in your app, or you can do it on a screen by screen basis. And that's really useful. But I'm still having an issue, like conceptually figuring out like a big app, like a Luno app or another app, the theming and the colors. And that's the one question. What kind of, because yes, we can do the conversion. And I asked that question about the conversion, or what is the kind of guidelines around how to handle theming? That's the first question. And then the other question is around packages and where to put all the things, because I can see that we can have like packages by feature and then start putting composed things in there, or you can have a separate module that has your design system in there. What are the guidelines or suggestions or ideas around that? So 2 questions.
I can probably comment on the theming front. Also have some opinions on the effectively like what you might call like the packages or architecture organization, really. But on the theming front, like I'm guessing this is somewhat similar to the question I got earlier, is that like if you have a big like XML theme or set of XML themes that you were using in your view-based app that don't just use the material attributes, like what do you do? And to be honest, at this point in time, like Compose offers, as I sort of showed you in the talk today, this material theme, which is strictly typed to material values. And then if you want to add additional values, you kind of have to take some of the approaches that I mentioned today of like extending a material theme and providing those via composition locals, etc. But there's also that tool, the Compose Theme Adapter library, which we offer, but that's pretty much strictly for take material theming attributes, pipe them to material theme, and the default values for both material design 2 and material 3. There isn't currently a tool that we offer like that for custom theming attributes and the many things that you could do in XML. It's, as I said earlier when I was answering that question, it's definitely something that I'm aware of. And if you can browse the source of that theme adapter library, and all that sort of like scaffolding is there for me to do that, to make it more flexible and allow you to support your own theme attributes. I just, to be honest, haven't got there. But it is certainly on the radar, and it sounds like it would be very useful. And it isn't the first time I've actually got this feature request. So there's that, and that's more like a to-do for almost for me, or to delegate it to someone else. But I would also say that like one part of this that is slightly more conceptual is that I think thinking about theming in XML is different to thinking about theming in Compose. The XML system was very flexible, so you can virtually theme like everything, well, not everything, but like a lot of things that sometimes aren't even UI related in your XML theme. I can't think of a very specific example now, but like one, although it is visual, like you can set your status bar colors and your navigation bar colors in your theme. But in a way, that's touching more on system UI and those sorts of areas. So in the Compose world, which is meant to model the material design system, that doesn't quite fit in. So I guess the point that I'm roughly getting to is that I would think more of Compose as like, is it a good idea to make something a composition local, i.e. like globally available? If it is, then like use some of the approaches that I've mentioned today. If it isn't, maybe migrate something that you would previously have done in an XML theme to another implementation in Compose, like a convenient function or some setup around like system UI or whatever. Yeah, I know that's a bit vague, but effectively, like, I think the XML system was so flexible that it made us think that like everything can and should be themed. But in Compose, I think they're trying to say, let's tone that down a bit, because that flexibility led to a lot of indirection and a lot of like misconceptions. And actually, if I think about it, like themes and styles are one of those topics that developers still to this day say, I have no idea how that works. And it's still something that we as Android dev role deal with and have tried to publish documentation for, but it still confuses people. So yeah, that's my probably more than 2 cents, more like 5 cents.
Yeah.
The matter.
So that means though that you're going to sit with like 2 sources of truth in a way, because the other thing is the styles, right? The styles, they don't go into theme, normally your XML styles, and those actually end up being attributes inside a particular component composable. Like because typically you would put a style on some other component, and then that style goes now inside the composable. So you're going to have the two things. You're going to have some of the things in the crazy complicated mess of XML, and you're going to have some other things which are just like part of compose. Yeah, that makes sense.
Yeah.
You can't really escape it.
No, I mean, there's the mental model doc of compose that I think is probably a good place to start with this, which is like thinking differently when you're implementing stuff in compose. But I get that there's this like world which people are living in now where they've got a view-based app and a compose app, but things like those styles, like default styles for components, things like other XML attributes that sort of stray beyond your actual app and even beyond UI, like I would personally say that those are things that we'd ideally move away from theming and rather do things like just create a separate file with your app's button in it and use that in place everywhere, or handle other aspects that you were theming in place where necessary. Like it is something that I do admit we probably need some documentation on. It's like a missing area, so to speak, but yeah, it's great.
So I guess if you see the theme as something that you'd want to switch, like for day night or for switching in a particular place that you want to have consistently switched through your app. The other things which are like values that are the same no matter what your app's doing, then that could potentially be. Anyway, that was just the first question. I don't know if Ahmed or Thomas have any comments on that.
No, I'm actually also curious about the question around the architecture, because so like my approach has been when it represents a screen, I have a UI directory, and then I have the different screens. So let's say if it's the dashboard screen, and then I'll have a package that will represent that, and then there I'll have the composable representing the screen, and then little components I'll have a separate area for them, and then widgets I'll have a separate area for them. So I guess at this point it's more like everyone kind of has their own approach, but like what Maya was saying, so is there like some sort of maybe recommended way of packaging things? So if someone was to go the module approach, where you have a module that now represents your compose app, then would that be ideal, or is it something that you just introduce, like in my case, introducing composable screens and having them lay separately with your normal fragments and all of that until you actually remove the fragments, that type of thing?
So I can tell you one problem that the module system has, right? So if you have a module with your design system in it at a separate level parallel to your app, you can't use any string resources in that module that the main app needs. So in that particular case, maybe the components and the design system sits in a separate module, but in the main app where the screens are, when you're busy building the screens, you probably still will have compose elements inside the main app because they need the resources that come from your resource system that matches the whole of the rest of the app. So there is certainly a sort of a split there. And then the other thing I'm thinking is there's like two schools of thought people. Some people say, like from the clean architecture point of view, people are saying if you look at the packages, you need to know what the packages are doing. Like, so you have like more use case or feature-based packages, which would mean then that your compose screens will be dotted in each of these use case packages. And then there's I've seen other people doing it by layer, you know, like they have all the data layer stuff and they have all the domain layer stuff. So it depends how you slice and dice your packages. Yeah.
I mean, coming from the Java enterprise world where we had all these discussions how the only true package distribution should be, now I tend to be a little more relaxed and try to advocate a pragmatic approach. probably it depends on the size of the app. There are some guidelines we get from the composed mental models. We need to make sure that our composables are testable individually. So we probably, I really like the way Ahmed described how he's doing things, because that sounded reasonable and not too much overhead from an architectural point of view. But frankly, there probably is no only true way of laying things out. So it probably also relates to how the communication with the data layer takes place and what data actually the app is dealing with. So probably I would try to be as pragmatic as possible and add additional layers of abstraction only if they are needed. I mean, at some point in time, the app is probably too big, so we need to have a true modularization scheme. But if we don't need it, maybe we can do without it.
Yeah, the benefit
Yeah.
though of having your design system in a module, sorry, Nick, is that you can package it separately and make a sort of an app that's like a showcase app of your design system. And then you can have that as a quick compile build thing, which doesn't build with your big app. Anyway, Nick, your turn.
Yeah, I guess I would agree with what everyone would say, yeah, but I'm going to do the classic Google thing and say there are some docs available. They're quite long, but I do, as someone said, like the mental model, the doc's actually called Thinking and Compose, is probably a really good one to start with. Similarly, there's docs on architectural layering and architecting your Compose UI. All of that is available on developer.android.com. And I'll also say that it's still quite young. Like even we are still kind of figuring that out, and we're doing it in, like you can probably see some of that thinking exposed in the Jetpack Compose samples GitHub repository, which is basically a bunch of samples that we maintain and experiment with. That being said, I will acknowledge that those samples tend to not be fully representative of these big real-world apps. That's something that we've been looking at and addressing. Can't really talk too much about it, but I'll also add to that is that like well, not the problems, but the approaches and challenges that we've listed yesterday aren't like, I wouldn't say exclusive to Compose. Like I remember having these similar discussions when creating a view-based app from scratch when I used to work at Over, and like we were discussing what architecture we're going to use. Are we going to use like MVVM, or we're going to use some kind of like a unidirectional data flow, or like why, how, who? And it kind of ended up being a case of this is what the team is familiar with, this is what suits the type of app that it is, and we tried something out and kind of liked it, and that's what works. Things will change with Compose, I think. I think if anything, I would hope that things would get simpler, and not like, no, they wouldn't need to necessarily overcomplicate our architecture if we don't need to, but because of that, like there's no longer that split between XML and Java and some of the complexities that came with the view-based system. But in any case, yeah, that's a bunch of thoughts I'm just going to dump there.
Nice. Thomas, your book, so does it actually, what level of developer would benefit greatly from it? Is it beginners, or is it more intermediate, or is it more advanced, or is it for everyone?
Actually, it's an introduction to Jetpack Compose, but I'm assuming knowledge of how to do Android apps. So I'm don't say anything about Kotlin as a programming language or how to set up your development environment. So I'm basically focusing on how to write Compose apps. So you probably need to have a solid understanding of how Android app development works. I do have some introductory pages where I compare the mindset of the traditional view approach, because we need to fully grasp the difference between imperative UI toolkits and the new declarative world. Because if we don't manage to do this mind shift, we probably won't be writing good Compose apps. So I'm do some sort of recap how the view system works, because I need that to show, here are key differences, you need to be aware of them. So that's the introductory part, and the remaining part of the book really focuses on Compose, and I'm not explaining other parts of Android app development. So like I said, you need a thorough understanding of how to do view-based apps to really get the real benefit of the book. Having said that, of course it's an introduction to Jetpack Compose, so I do some peeks under the hood, because I feel it is necessary to see how composition, recomposition works. I need to explain some of these things, but it's not it's really not an internals book. So if we want to know how to Compose works under the hood, I would probably refer everybody to Jorge Castillo's Compose Internals, which is an awesome read. So my book tackles more the how to do UI point of view.
Very nice. I'm actually looking forward to reading it. I actually have it on pre-order. Yeah, I'm excited.
Awesome, thanks.
Yeah, so I guess just to round.
Sorry, I actually missed what you said there.
A Siri decided to take over my laptop there and thought I was giving a command. Yeah. So Nick, do you have any thoughts? So someone who's new to Compose, or maybe someone who's an existing developer who's looked at this thing, is hesitant to actually adopt it, what would you say to them?
That's the money question right there, I guess. No, I would say the feedback that we've received from most developers is that there's curiosity. And I would say, if you are curious about it, just try it out. It is a new toolkit. It's not fully done yet, but it is certainly an area where Android is investing a lot of its time and future investments towards as the, let's say, next main toolkit of Android. It can't fully replace your view-based app yet, but it's close enough for you to have parts of your UI and at least share that in a production app at the moment. Plus, if we consider that the investment from JetBrains into some of the multi-platform areas, like Compose for desktop, for example, I think there's a lot of potential there for this to be a toolkit of sorts that allows you to write once, run everywhere. But for now, it is certainly the space where Android is getting the most amount of attention. And there's a lot of basically entry-level beginner courses that we have, code labs, documentation, and then these new things called pathways, which basically combine code labs and docs and videos into this sort of stream bit of work, which you can find on developer.android.com. But again, the great part about it is that we also have Google developer experts like Thomas and third-party things for you to learn from, which are just as equally valuable, so that you have both sides of the story. You have Google side, you have the external side, and sometimes actually need both, because that experience of using it in a real world and externally and in production apps in the Play Store is invaluable. So in a nutshell, at the very least, try it out. Maybe make a little playground app. Maybe try and pitch for it to be introduced in your company if you're an Android developer, and have a test screen that you don't necessarily ship to production yet. Try and migrate a screen and see what pain points you come across. And at the end of the day, complain to me on Twitter when you come into, actually don't do that, or do that sometimes, but complain a little bit when you come across things that don't work, because ultimately that helps to improve it. Yeah.
Or invite you on a panel and ask you tricky questions.
Yeah, just watch me squirm as I figure out how to answer this in an official way.
Thanks so much, Nick. No, that was a great question. Great answer. Sorry. Yeah, Maya, do you have anything to add?
No, I don't want to make Nick squirm anymore, so I haven't got anything else to add. But I just want to say this is super interesting and super useful on both accounts. So thank you.
No, I totally agree. And Thomas, Nick, thank you for giving us your time and giving us two really great talks tonight. I'm pretty sure our community has benefited greatly from them. I surely have. I learned a lot from the material side as well as foldables, which I had no clue. At least the deeper knowledge that I got today was actually really nice. So thank you for both of you for sharing your time. And yes, thank you to everyone who joined tonight at our meet, which was a deep dive into Jetpack Compose. Thank you so much for joining. And yeah, till we see each other again. Bye, everyone.
Thanks.
Thank you. Bye.
Bye.
Bye-bye.